Hello everyone, welcome to another video on differential calculus. I'm still looking at past exam papers and just one more question on rules of differentiation and first principles, and then I'll be moving to university stuff like I promised in the previous video. So here I have a question here, question one there, first principles, and then equation of a tangent, and we are going to look at rules of differentiation and a bit of application there, 19 marks. So this should be quite short, perhaps maybe around 21 minutes, somewhere there. All right, so let's go straight into it then. Question one says f of x is equal to 3x squared plus 4x. That's 1.1, 1.1.2, sorry, 1.1.1 says we're supposed to determine f prime of x using first principles, and 1.1.2, find the equation of a tangent to f at a point where the first derivative of x equals -2, and we know that that should be the gradient. By definition of derivative is gradient, so that should be the gradient, but at f prime of x equals -2, so we're supposed to determine the value of x and the value of y. Gradient has been given there, and then we moving on to the other aspects of this question. So let's go straight into it then. Question one, and this is page 1 here. We have 1.1. It's given that f of x is equal to 3x squared plus 4x, and so 1.1.1, we're supposed to determine f prime of x by using first principles. So here we go. So f of x, this has been given as 3x squared plus 4x, and therefore f of x plus h, this should be equal to 3x plus h all squared plus 4, and then x plus h. Continuing, we have 3. Remember what I taught you last time on this one, x squared plus 2xh plus h squared, and the last part is going to be 4x plus 4h. Expanding this, we have 3x squared plus 6xh plus 3h squared, and then plus 4x plus 4h. Going into the formula, f prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x all over h. Substituting the two expressions, that one and that one, into the formula, we're going to have limit as h approaches 0 of 3x squared plus 6xh plus 3h squared plus 4x plus 4h. Remember, I told you must always use brackets there, and we have 3x squared plus 4x. That expression there, it must go in there, all over h. Removing those brackets there, we have a limit as h approaches 0 of 3x squared plus 6xh plus 3h squared plus 4x plus 4h, and then minus 3x squared minus 4x all over h. Cancelling what we can. This cancels that, and the 4x cancels the 4x there. What do we have now? We have limit as h approaches 0 of 6xh plus 3h squared there, and then plus 4h all over h. Factorizing the numerator, we have limit as h approaches 0 of h open bracket 6x plus 3h plus 4 all over h. Cancelling the h, we have limit as h approaches 0 of 6x plus 3h plus 4. Now as h approaches 0, the 3h will approach 0, and our final solution then is going to be 6x plus 4. That is the derivative of that function from first principles. Right. Next, so that was 1.1.1. Mark distribution, we have 4 marks for that. You should have an idea by now looking at the previous videos. It's 4 marks here. You can see 4 marks, and the 4 marks should be distributed as follows. You have 1 mark for that. Everything here simplifying up to here, 1 mark. Common factor and cancellation, 1 mark. And the final answer there, 1 mark. So it's 4. Let's go to page 2, and we're going to look at question 1.1.2. Page 2 here. Question 1.1.2 basically says that we are supposed to, here it is, find the equation of a tangent of the tangent to f at the point where f prime of x equals -2, 5 marks. So we are told that f of x is equal to 3x squared plus 4x, and we're also given that f prime of x is equal to -2. This tells you that m tangent by definition is actually equal to -2. So we know the value of m. All we need to do now is determine the point of contact. Now we are told f prime of x. So this, we've already done the differentiation of that. And what did we find? We found 6x plus 4. So we are going to say this equation here implies that 6x plus 4 is actually equal to -2. We're supposed to solve that. So I'm going to subtract 4 from both sides. We're going to get 6x equals -2 minus 4, and 6x equals -6. Dividing by 6 both sides, you get x equals -1. Right. Now, when x equals -1, what will be the value of y? Now, so what we're saying basically is we know that y is equal to f of x. And what is f of x equal to? 3x squared plus 4x. And then we're going to say at x equals -1, we got -1 there. What will be the value of y? Y will be equal to f of -1. And what is f of -1? We're coming here and there. Will be 3 minus 1 squared plus 4 times -1. Right, simplifying this part here, remember -1 squared is 1, times 3 it will be 3, -1 times 4 it will be -4, and what do we find? -1. That's the value of y. So we're now having a point. That point is -1, the value of x. The value of y is also -1. So there is your value of y, and that's value of x, -1. I'm going to call this x1 and that y1, as you have seen in the previous videos. So we have our gradient and we have our point. We're going straight to point slope formula. Y minus y1 equals m, and then x minus x1. Remember what I told you last time? Use brackets. Y minus, open brackets, close. Our value of m is -2. Over here, you can see -2. That's the value of m. X minus, I'm going to use round brackets inside there. What's the value of y1? -1. We put -1 here, and we also put -1 there for the value of x1. Simplifying on the left hand side, we have y plus 1 is equal to -2, one step at a time. Inside here we have x plus 1. Expanding that, we're going to have y plus 1 is equal to -2x minus 2. Subtracting 1 from both sides, it takes us to a solution that says y equals -2x minus 3. And that is our final equation. That's our final equation. Now, marks distribution, how many marks does this one have? Well, this one has, if you can see here, 5 marks. And here is how I would distribute the 5 marks. The 5 marks would be distributed as follows. 1 mark would be for the value of x. That would be 1 mark. Another mark would be for the value of y there. Substitution, final answer, we have 1 more mark left. And that mark would be equating the derivative to -2. That would be 1 mark again. So that's 5 altogether. Right, let's move on to the next part, which is question 1.2, because we're done with 1.1.2. Now we're going to 1.2, rules of differentiation. Right, let's go to page 3. page 3 here. What do we have now? 1.2. 1.2 says, and we have 1.2.1. 1.2.1, it says here y is equal to 4x squared and then minus 3x power 5, and then we have plus 2 over x squared. There it is. We're supposed to determine dy dx for 3 marks. All right, so here I have to rewrite this. So we have y equals 4x squared minus 3x power 5 plus 2x power minus 2. Now I can differentiate. Therefore, dy dx now must be equal to 8x minus 15x power 4 using rules of differentiation. Remember, you must multiply and then reduce power by 1. Do the same here. You're going to get this. 5 times 3 is 15. Of course, there's a minus sign, and less 1, 4. Here, it's going to be minus 2, or if you like, one step at a time, like so, x power minus 2 minus 1. Simplifying that, we get 8x minus 15x power 4, and then minus 4, x power minus 3. Going a step further, 8x minus 15x power 4 minus 4 all over x cubed, respecting the format in which the question has been presented. So this would be the final solution. This question has 3 marks. This is how I would distribute the 3 marks. I would put a mark on each term basically. I wouldn't give a mark there because of the 3 marks. So I would basically say that the 3 marks should be distributed as follows. I would put a mark there, and a mark there. 3 marks. And normally this should have been 4, so that this would have earned a mark. By expressing that in that form, you would have scored a mark. But 3 marks, it means that each term has to have 1 mark in the final solution there. Now 1.1.2.2, what do we have? We have derivative. Here is the differential operator again with respect to x of, we have x squared minus 3x minus 10 all over x plus 2. When it's like this, you have to factorize the trinomial in the numerator, the quadratic function. Factorization of that has been covered in my first few videos on algebra. Please go and revise that. I'm just going to go straight here and say this is the same as derivative with respect to x. Factorizing that, it will be x minus 5 and then x plus 2 all over x plus 2, like so. Let me put this in brackets as well. As you can see, we need to do the cancellation now. Performing the cancellation there, we have this term cancelling that term, and our final but one step, this is what we have, x minus 5. And so derivative of x is 1 and derivative of minus 5 is 0, because the derivative of a constant is 0. So this would be your final solution. How are the 3 marks distributed? We have 3 marks here. How are these 3 marks distributed? You're going to get 1 mark for the factorization of the numerator, and then you're going to have 1 mark for the x minus 5, and then you're going to have 1 mark for the final answer. This is how I would distribute the 3 marks. We are going to 1.3, which is the last one in this video, short 1.3. That's page 4. Page 4. Here is page 4. Right, just want to make sure that you are able to see what I'm writing here. So that's page 4. And I want to talk about 1.3. So put the papers in order. Right. So 1.3, here it is. What does it say? It says here, if or given f of x equals ax cubed plus bx squared plus cx plus d, we are told if f prime of x equals 9x squared plus 8x minus 7 and f of 0 equals minus 4, find the values of a, b, c, and d. 4 marks. All right, so f of x is equal to, let's capture what we are told, or given ax cubed plus bx squared plus cx plus d. We are also told that f prime of x is given as 9x squared plus 8x minus 7, and we're given f of 0 equals minus 4. So we're supposed to find the values of a, b, c, and d. So how do we go about this? Well, here's how we go about it. We differentiate that with respect to x. So we're going to say, therefore, f prime of x from that one there will be equal to 3a x squared, if you can see there, and then plus 2bx plus c. Derivative of d is 0 because it's a constant. We have been given this expression. There it is. It means I'm going to say here, this is equal to 9x squared plus 8x minus 7. That tells me I must equate coefficients now. So 3a must be equal to 9, and then 2b must be equal to positive 8, and finally the last term there must be equal to the last term. So I'm going to say, therefore, 3a equals 9. What is a equal to? Divide by 3 throughout, you get a equals 3. Next, I have 2b equals 8. What is b equal to? Divide by 2 both sides, you're going to get 4. And finally, your final step is c equals minus 7, obviously. From there, you can see. Now, I know a, b, and c. Take these into there, or you don't actually have to, but let's just put them in. So we have f of x. Therefore, f of x is 3 x cubed, and then put 4 there. It's going to be plus 4x squared, and then c is minus 7. Put minus 7 there. You're going to have minus 7x plus d, and we are told that f of 0, according to this, if you punch f of 0 here, it will be 3, 0 cubed plus 4, 0 squared minus 7 times 0 plus d. This has been given as minus 4. You'll see that all these collapse. It tells you that d equals minus 4. So we can say, therefore, a equals 3, b equals 4, c equals minus 7, and d equals minus 4. So this would be the end of this short video. And in this one here, it's 4 marks, as you can see, 4 marks there. How do we distribute the 4 marks? As follows. Each answer will just have 1 mark. So it will be 1 mark for 3, 1 mark for 4, 1 mark, and then finally 1 mark, and that's 4. Right, this is the end of this video. The next video is going to be on the product rule, and then I'll go straight to the quotient rule, and then pause a little bit, and then come back with the chain rule. All right, so if you're new to this channel, please help us by subscribing and liking these videos, sharing them, inviting friends to subscribe to our channel, and it will help us build the membership for the channel and be able to give us the support we need to produce many more videos. All right, I'll see you next time. God bless. Bye-bye.